Alright, kiddos, if you're watching this video, that means you didn't do so hot on your test. That's okay, because I'm going to teach you how to do the things you didn't do so hot on today. Okay, so the first question is, what is the prime factorization of 420? So we're going to try and find all the factors of 420, but the factors have to be prime. This is hugely important. So let's start with the question. So 420, because it right here it ends with a 0, it means it's divisible by 2. So we can divide out of 2, and we end up with 210 left over. 210, because it ends with a 0, means that it is also divisible by 2. So we can factor out another 2. We end up with 105. Now, 105 ends with a 5, meaning that it's divisible by 5. Okay, and that gives us 21. And 21 is divisible by 3 and 7. Okay, so another way to write this, we could say that 420 is equal to 2 times 2 times 3 times 5 times 7. Okay, or we could say in exponential notation, 2 squared, because we have 2 2's, times 3 times 5 times 7. And if we actually multiplied this out, it should equal 420. Let's see. 4 times 3 is 12. 12 times 5 is 60. 60 times 7 is 420, and it does. So the prime factorization of 420 is 2 squared times 3 times 5 times 7. Okay? Let's get the 2, the 5, the 3, and the 7. Alright, let's look at another problem here. What is the GCF of 36 and 60? Okay, the way we do this, you can do the t-charts. You can do 1, 36 are factors of 36. 2 and 18 are factors of 36. Because if you add the digits together, 3 plus 6 equals 9. That means it's divisible by 3, and it's 3 and 12. 4 and 9. It's not divisible by 5. It's not divisible. Yeah, it is divisible by 6. 6 and 6. Okay, and then for 60. Okay, 1 is 60. It ends with a 0. It means it's divisible by 2. It's 2 and 30. If you add the digits together, it equals 6, and 6 is divisible by 3. Okay. 4. Let's see. 4 goes into 60. There's not really a special trick. Just knowing that 4 goes into 40 10 times, and you have 20 left over, it goes 5. So it would be 15. Ends with a 0, so it's divisible by 5. If it ends with a 0 or 5, it's divisible by 5. So that's 5 and 12. It's divisible by 6 and 10. And let's see, 7, no, 8, no, 9, no. Alright, so the factors they have in common. They got a 1 in common. They have a 2 in common. They have a 3 in common. They have a 4 in common, 6 in common. Where I circle that 6, we'll circle it again. Not 9. Oh, they got a 12 in common. Not 18, and not 36. Alright, the greatest one they have in common, so the GCF, the greatest factor in common, is a 12. Okay, now, another way to do this real quick is you can do the prime factors. So 2 and 18, 2 and 9, 3 and 3. So 36's prime factors are 2 times 2 times 3 times 3. And the prime factors of 60, 2 and 30, 2 and 15, 3 and 5. So 60 equals 2 times 2 times 3 times 5. Now all we have to do is find the ones that they have in common, and that will give us the prime factors, or that will give us the GCF. So they both have a 2. They both have a second 2, and they both have a 3. Okay. They don't have the second 3 in common, and they don't have a 5 in common. So another way to calculate GCF is just to take the prime factors that the numbers have in common. You can do this for 3 numbers, 4 numbers, 5 numbers, as many numbers as you want. The prime factors all have to be in common for all the numbers. Okay, so 2 times 2 times 3. 2 times 2 is 4, and 4 times 3 is 12. So see, we still got the same answer as we did over here, just a little bit less work. The GCF is 12. Okay, let's see here. What is the LCM of 12 and 14, the least common multiple? Okay, so we're going to go right into the quick method for this. You can find the prime factors, 2, 6, 2, 3, and the prime factors of 14, which are 2 and 7. Okay, so that means 14 is actually the same as 2 times 7, and 12 is equal to 2 times 2 times 3. Now, to find the LCM, this is just a little bit different. You have to include everything has to be included in the equation. So the LCM for 12 and 14 is equal to, so I have to have at least 2 2's and a 3 because of 12. So 2 times 2 times 3. And I already have a 2 included right here, so this 2 is included. But I don't have a 7, so I have to add the 7 to the equation. Okay. So I didn't add the 2 for 14 because I already have it listed here. But I don't have a 7 listed. The ingredients have to be included. Okay. So 2 times 2 is 4. 4 times 3 is 12. And 12 times 7, well, let's see. 12 times 7. Alright, gives us 14. Carry the 1. 7 times 1 is 7. Plus 1 is 8. So I end up with 84. So the least common multiple of 12 and 14 is 84. Okay, 12 will go into 84, let's see, 5, 6, 7 times, and 14 will go into 84, let's see, 84, 14, I want to say 6 times. 6 times 4 is 24. Carry the 2. 6 times 1. 6 plus 2 is 8. Alright, no remainder. It goes 6 times. Okay, so that is how you find the LCM using prime factorization. So we've looked at how you can use prime factorization to find LCM and to find GCF. Remember, LCM, we're trying to find multiples, which multiples are like multiples of 12 are like 12 times 1, 12 times 2, 12 times 3, and so on and so forth. We're trying to find ones that they have in common that are the least one that they have in common. Okay. This next question, put in order from least to greatest. Okay, so we've got all these numbers. Now when we're dealing with decimals, we want to make sure we have the same place values before we start putting them in order. Okay, notice that this goes out to the tens, the hundreds, and the thousandth spot. And this goes out to the thousandth spot, this goes out to the thousandth spot, but this only goes out to the hundredths. So the way we fix that is we just add a 0 placeholder. So we 4.11 and 0. There we go. So now this goes out to the thousandth spot. And same with this one. 4.010. Okay. So now we can put these in order. Okay, so I'm just going to go ahead and rewrite all these so they're all kind of on the same level. It's 4 and 13 thousandths. This is right here 4 and 9 thousandths, and this is 4 and 403 thousandths. Okay, so the smallest number is going to be the 4 and the 9 thousandths. So I'm going to rewrite that. Say, okay, 4,009 thousandths is the least. Okay, so I've done this one. The next smallest is going to be, right here. This is 10 thousandths. This is 110. So 110 thousandths is way bigger than 10 thousandths. So we're going to save that one for later. 4 and 10 thousandths. See, the key is how you say it. Okay, so it's 4 and then this is 10. That's a 10 thousandths because it's in the thousandths spot. Okay, we've done that one. Oh, sorry. We've done this one. Okay, next we have 4 and 13 thousandths. And then we have 4 and 110. 110 thousandths. By adding that 0, now it's 110 thousandths. And 110 thousandths is bigger than 13 thousandths. It's bigger than 10 thousandths. It's bigger than 9 thousandths. Alright, and that leaves us with 4 and 403 thousandths, which is the largest number. Okay. Y'all did a great job sticking with me here. Alright, put in order from least to greatest. Okay. Before you can compare fractions, the denominator is the bottom number. They all have to be the same. So you have to find the least common denominator. Or you could say the least common multiple of the denominator. That's another way to say it. So we have 16, 2, 6, and 12, and we have to find the least common denominator of those. Okay, so it's another opportunity to practice this prime factorization method. So the prime factorization of 16, the denominator, is 2 and 8, then 2 and 4, then 2 and 2. Alright, for 2, it's already prime factorized, it's just 2. Alright, for 6, it is 2 and 3. Okay, and here, let's do that in a different color. Alright, it is 2 and a 3. Okay, and for 12, it is 2, 6, 2, 3. Alright, so if we're going to write, if we're going to find the LCD, the least common denominator, or the least common multiple, the equation is going to have to include at least these 4 2's. Okay, so let's go ahead and put this in blue. Times 2, times 2, times 2. Alright, this 2 right here is already included. This 2 from this equation is already included as well, but we don't have a 3 in there, so we have to come in here and add a 3. Alright, so we satisfy that. So far, we've satisfied 16, 2, and 6, but now we have to have 12. And let's see, the 2, we have 2 2's. Well, we have at least 2 2's right here. Okay. Let's change it to red. At least 2 2's in that equation, and we have to have a 3, which is already included. So we have all the ingredients from the prime factors. You know, we have to have at least 4 2's, and we have to have at least 1 3, because 2 of these have a 3. Okay. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2, 16, and 16 times 3 is 48. Okay, now you can also, if you don't know that right off the bat, you can do it. You can write it out. You can go, okay, well, 6 times 8 is 48. Carry the 4. Okay. And then, well, I don't know what I was just doing there. Should be a 3. Sorry about that, guys. Okay, there we go. That will give us 18. Carry the 1. 3 times 1 is 3, plus 1 is 4. Gives us 48. Alright, so least common denominator is 48. Okay, now we have to take these fractions and convert them to a denominator of 48. So we have 9 over 16. And if we multiply 16 times 3, multiply the numerator right here by 3, you end up getting 27 over 48. Okay, the 1/2, multiply this times 24 and this times 24, we end up with 24 over 48. 4 over 6, and multiply this by 8 and this by 8. We get 32 over 48. And now we've got 7 over 12. If we multiply this by 4 and this by 4, we get 28 over 48. Now we can compare. Okay, 24 over 48 is the smallest. That means 1/2 is the smallest. So if I'm putting these from least to greatest, this is the smallest. Okay, so I'm going to put 1/2 right here. Alright, the next smallest is 27 out of 28, and that represents 9 over 16. Okay, the next smallest is 28 over 48, and that's the 7 over 12. Alright, and then 32 over 48 is the largest fraction, and that represents the 4 over 6. And that is how you put fractions in order. Always get the denominators the same. Get the least common denominator. Okay? Then you can compare. If you just try to compare looking at the fractions, you're not going to be able to do that. The denominators have to match. So you have to find the least common denominator. Okay. Number 6 here, simplify the following fractions. Okay, to simplify, all you have to do, like for example for 24 over 100, is you have to find a common factor of 24 and 100, and you just divide out the numerator and the denominator. Okay, so let's do the first one. Let's simplify this one. I'm going to rewrite it right here, 24 over 100. Now they both, this ends with a 0 and this ends with the 4, so I know I can divide out at least a 2. Okay, so I end up with 12 over 50. But this ends with an odd number, and this ends with an odd number. So I know that I can divide by 2 again. And so I get 6 over 25. And 6 and 25 do not have any common factors. So now this fraction is in the lowest terms. We always get the fraction in the lowest terms. Okay, that means that there are no more common factors that we can factor out. 6 has factors of 1, 2, 3, and 6. 25 has factors of 1 and 5 and 25. None of those are the same. So we're in the lowest terms now. When we do the same thing for 27 and 90. Okay, you could also, if you wanted to, if you were wise, you could say, okay, well, 24 over 100 is actually divisible by 4. Both are divisible by 4. So you could get right to 6/25 without having to do it twice. But you can still do it twice, you get the same answer. Either way, you get the same answer. Okay. Let's find the simplest terms for this one right here now. 27 over 90. Okay, let me show you a quick trick. You add these two digits together, 2 plus 7 equals 9. That's divisible by 9. 9 plus 0 in the denominator is also divisible by 9. So I can actually factor out a 9 from the numerator and the denominator. They have a common factor of 9. 27 divided by 9 is 3. And 90 divided by 9 is 10. And there we have it. In its lowest terms, 3 and 10 do not share any common factors. This has been fully simplified to 3/10. These fractions are the same. 27 over 90 is the same as 3 over 10. They mean the same thing, but this is 3 over 10 is in the simplest terms. Okay, and the last problem. Alright, to put an order from greatest to least, okay, 0 and 51 hundredths, 0 and 6 hundredths, and 1/3. Okay, these are in different terms. We've got a fraction right here, and we've got decimals right here and right here. So we have to convert either all the decimals to fractions and then simplify and get the same denominator, or we could just change or convert this 1/3 to a decimal and then get the same place value. So we're going to do the second option. That's a little bit quicker. Okay. So remember, top dog goes in the house. Top dog goes in the house. Okay. So that means that this one right here is the top one. Doesn't matter if it's bigger or smaller. Doesn't matter if it's curvy or round or even or odd. it doesn't matter. Whatever the numerator is, the numerator is going to go in the house when you do your division. So when I'm converting, so I put the 1 in the house, I put the 3 outside. 3 does not go into 1. Okay, so we add our decimal spot right here and here, and we add a couple zeros to extend it out. Now 3 does go into 10. It'll go 3 times. Okay, 3 times 3 is 9. Okay, 10 take away 9 is 1. Bring down the extra 0. 3 goes into 10 3 times. 3 times 3 is 9. Okay, so I know I have a remainder of 1. The problem will go on and on. So really, 1/3, let's write this right here, 1/3 is equal to 0 and 33 repeating. Okay, so now I've converted it. So I've got this right here, which is actually equal to 0 and 33, and they're all in the same place value. Okay, so this is 600ths. 600ths is the least. You got 33 hundredths, which is bigger, and then you got 51 hundredths. 51 hundredths is bigger than 33 hundredths and 6 hundredths. So it says put an order from greatest to least. So greatest to least. So the greatest is 0 and 51 hundredths. The next is 0 and 33 hundredths. Dot, dot, dot. Alright, and then the least greatest is 0 and 6 hundredths. So 6 hundredths is smaller than 33 hundredths, which is smaller than 51 hundredths. Another way you could write this is that 0 and 51 hundredths is greater than 0 and 33 hundredths, which is greater than 0 and 6 hundredths. This is also representing a third. So you could write it like this. A third is greater than 0 and 6 hundredths. Okay, well, this about covers all the concepts. Hope you watched the video. If you have any questions, bring them to class and be ready for that retake. Thank you for your time and have a wonderful, wonderful afternoon.